Basically, how the geometry created is when they start to pin on the pin on one point, and then they name it as a point. When there's like a one dot, it's a point, right?
Yeah.
And then they start to think, what if they just moving their pen, let's say like pen or pencil, moving their pen or pencil, it creates
Line.
a line, yes. And then what's next? When there's two line midst, when there's two line midst, this is
Perpendicular.
no, it's not mid at the perpendiculars. When there's two line mid, this is
An angle.
an angle, yes. Okay, we know that when there's two line mids, it's still not a closed shape, right? In
Yeah.
order to make it a closed shape, unless there
Yeah.
will be the
We have to like make it like close. Like we have to like it can't be open. You know,
yes, so at least it have to be
three lines.
three three line or three side, yes. When three side, this is called
Triangle.
triangle. This is called triangle because like the word tri is represent three, right?
Yeah.
Trees. Okay, so three line is triangles. How about a closed shapes with the four line?
It's a quadrilateral.
Quadrilateral. Okay, so closed shape with four line is quadrilateral. Three laterals.
Hmm.
Okay, now we will talk about the quadrilateral. We know that quadrilateral. Now they focus on quadrilaterals.
Yeah.
Okay. When there is one opposite sides are parallel. So first of all,
Yeah.
the word parallel. Parallel means
When two lines never touch. When two lines never meet, they just like
they are parallel. So parallel is two line never meet. So for
yeah.
example, this is like a regular quadrilateral. But in a special case, when there's two opposite sides are parallels, this is
Um, I forgot what it's called. It was
so these are
like a trapezoid. Or,
yes. So this is trapezoids. So this is trapezoid. Their condition, let's say, okay, let's name it as A, B, C, D. So when AB parallel to CD, this is a trapezoid. This sign is parallel sign. I will draw it like
yeah.
yeah. Okay. So this is trapezoid. And inside of trapezoid, we have two types. First is
Inside of a trapezoid,
in the trapezoid,
we have two types of angles.
we have two type of trapezoids. The
What?
first one, okay, like
Oh,
the mathematician still like considering and like, okay, trapezoid have to be two opposite side have to be parallel. What if
yeah.
the two side, the two other sides are equal? Let's say this equal to this. A, B, C, D. So trapezoid is just two opposite side AB parallel to CD. AD and BC, we don't care. It's equal or not equal, we don't care. But for this case, they started things and what is AB parallel to CD? And these two sides equals.
Rectangle.
What should we name them? Two side equals.
Wouldn't it be like a rectangle or?
It's a. What do you think would be there?
So they're both equal, right?
Wait, I think.
Like no, they're okay.
Uh, have you studied triangle yet? Oh, not yet. Okay. So when two sides are equal, we call it isosceles.
Oh,
Yes, isosceles trapezoid. Trapezoid. Right?
when A, D, and B, C are equal, it's an isosceles triangle.
When AD, okay. So first of all, to make this ABCD a trapezoid, AB have to be perpendicular to CD, correct? But
Yeah.
for this case, AD, this side, AD also equal to BC. So we have
Yeah.
two opposite side equal, two opposite side parallels. Okay. So then this is called isosceles trapezoids. And then the other ones, they still think, okay, so trapezoid to opposite side parallel. What if this angle is a right angle? What if this angle is a right angle? Let's say AB, CD. If we have AB parallel to CD, and angle A, let's say angle A is 90 degrees.
Hold up. I have to. Can I get my notes or? Because I think we did like.
Okay, okay. This is a new topic, so you need to take a note.
What?
Your note is like a paper or a notebooks.
Paper.
Oh, that's easy to throw away. Okay, I don't get this. Okay, laterals, quadrilateral.
Yeah, it's no paper, like paper, you know?
Yeah, but should be done in the notebook is better. Why? Because it's not easy to throw away. If it notes paper, okay, like a note, then like,
Isn't it like an isosceles right triangle? Or?
okay. So for this,
Wait, no, it's not. Sorry. Never mind.
two side is not equal, but one angle is a right angle. When it's 90 degrees, it's called a right angle, right?
Yeah.
So then they name it as right trapezoids.
Right.
Right trapezoid. Okay. Here have the like a quadrilateral discussion happen. Okay. Next, so Basically, now two opposite sides are parallel, right? Two opposite sides are parallel. AB and CD are parallel. So,
Yeah.
what if two pair, not just two, but two pair of the opposite side are parallel? Still, it's inventing from the quadrilateral. So now, when two parallel, so these two opposite sides are parallel, and also the other two opposite sides are parallel as well. Yeah. So let's name it as A, B, C, D. So when AB parallel to CD, while AD also parallel to BC. Okay. AB parallel to CD, also AD parallel to BC.
Yeah. Wait,
This,
A B is parallel to DC. I mean CD, right?
yes, AB parallel to CD, so two opposite sides, AB and CD parallels. AD and BC also parallels. This like parallel, we call it,
A parallelogram.
yes, parallelogram. So this is called parallelogram. Okay, parallelograms. Wait. Okay. One minute. Okay. Okay. So from these parallelograms, what if there is one angle, let's say at angle A become 90 degree. So the shape will be AB to CD here, CD here, and then angle A here is right angle. Then the shape will look like this.
A rectangle.
Yes, that is a rectangle. So AB parallel to CD, also AD parallel to BC, plus condition A, angle A is 90 degree. This will be called rectangles. Okay. Rectangles. More than that, what are the shape? Okay. More than that, if there is two sides, we call two adjacent sides, AB, CD. Okay. What if we have one right angle and one adjacent side? Adjacent mean next to each other. AB equal to AD. A rectangle that have two adjacent sides are equal. This is
A square.
a square. Let's put it here. So rectangle, rectangle with two adjacent sides, AB equal to AD. This is
Square. Are you talking about the square?
yes, it's square. And next one is a parallelogram. Okay, I can explain it. A parallelogram, but two adjacent sides. So okay, here, 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 here. So this is it's a parallelogram, but there are special cases. Two adjacent sides, this equal to this, and this equal to this. Two adjacent side, this. AB equal to AD, AB equal to AD. Okay, let's name it A, B, C, D. AB equal to AD, and BC equal to CD. This is called what is
Hold up.
parallelogram with AB equal to AD, BC equal to CD. That is
I know what that is, but I forgot the name.
mm, name is parallelogram with AB equal to two adjacent sides cycles.
Isn't one of those a rhombuses?
Yes, it's called rhombus. It's called rhombus. Rhombus. Okay, that's called rhombus. The other one, but it's not very uh, useful in the geometry. Not very useful, but not popular. It's useful, but not popular in geometry. Is only the adjacent side equal.
Oh, it's a diamond.
We don't call it diamond. We call it
Oh, kite.
chi. Yes. So the diagonal are perpendicular. So their diagonals perpendicular perpendicular. It's called chi. Mhm. But actually, like chi is in the practice, like oh, we can fly a kite. It's a geometry shape as well. That also the geometry shape. So there's a lot of shape, right? But today we will only focus on the parallelograms. Parallelogram. Because like okay, parallelogram is the first one, so we study parallelogram, and then like a rectangle, square is like the invention of the parallelograms. So let's do with some parallelogram. We know that in parallelograms here, in one parallelogram here, A, B, let's name it as A, B, C, D. Okay, A, B, C, D. How do we find the area of a parallelograms? How do we
We find base times height.
base time highs? So from this figure, what are the base? Where are the highs?
It's from the corner of A to like down to like
Hmm.
straight down.
Straight down. It's we call it perpendicular. So from A perpendicular to BC is a high, right? The
Yeah.
distance from A perpendicular to BC is called high. When we use this high, the base have to be CD.
The length. Or
Yes,
yeah.
the base have to be CD. Okay. What if we use the height from A but perpendicular to BC? So if we use this height, can we use this height?
We can use them, yeah.
Yes. So when we use this height, the base will be
The BC.
BC. Yes. Okay. So basically, the area of the parallelogram is base time high or high time base six. Do a quick example. then we can have the ideas how parallelogram come from. So we have two shapes. Example one here. Example no. This is example. Calculate the area of each parallelograms. Okay, let's let's see the parallelogram shape is where's this? Okay, we use this. We have one here, 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 okay, here, and here. Okay, this with the is a parallelogram. Let's say no fields. Okay, let me take a little time to draw to make it more accurate here. So the side from here to here, we know that it's 5 centimeter. This is 5 centimeter. Okay, this is 5 centimeter, and this one is 7 centimeter. Does it look like parallelograms?
Yeah. It kind of looks like
A
a
little
square, but like
curve here, like a little bit
yeah,
curve here, but okay. Let us zoom this is a
it
part.
looks like one of those like 3D squares. You know what I'm talking about?
Okay, okay. Okay, so this one, next one is hey, where's wait, here. Okay, this one again. This one like bends here and then okay, it should look like in a flip way. Okay, here. Okay. Okay, 1 minute. So we have this perpendicular here is 7. Okay, wait. Don't boring yet.
Yeah.
Okay, 7.5 and then here is is 2 point. Okay, so calculate the area of each of parallelogram, and we have the figure here, A and B. This is A. This is for A. Okay, I think you can catch up easily, and you can do it. Right.
Okay.
Okay, so let's try. So the area of first parallelogram is what, and the second
35.
is okay. So the area of the first parallelogram will be 7
35.
times 5.
Um,
Yes, 5 times 7 the same. It's equal to 35
35 centimeters squared.
centimeters square. Why it's centimeter square?
Because we're doing area.
Because we're doing area, and in terms of that, it should be actually if we include the units, it will be like 7 centimeter times 5 centimeter, right? So centimeter with centimeter, also centimeters. Yes. Okay. Next for the area of B, the
187.5 or
okay. So when we use this high as a high, so when this is a high 7.5, the base should be here, correct?
yeah,
Yes, the base should be here.
which is 2.5.
Yes,
Oh,
but in
okay.
parallelogram, these opposite sides are equal, correct? Are
Yeah,
equal. So when this 2.5, the base also 2.5. So times 2.5, it's equal to
I got 187.5, but
187. Okay, let me confirm. Yes,
what
187.5 centimeters. That's correct.
squared? Okay.
Yes, that's correct. Okay. Let's do something. Okay, not. Okay, let's do one more. Actually, we not let's actually also when we study geometry, we also learn how to draw. But
Yeah,
that have to be like you have the ruler here, you have the ruler here, draw shape, house. But
yeah,
I think you already know how to draw, right?
yeah.
Okay.
How do you know that?
Because you already like even know how this is named. So this is parallelogram, this is trapezoid, this is this.
Yeah.
I mean
Okay.
you know some or maybe have some idea on this already. But anyway, we have the lesson on that, so we need to go ahead with that. It's in
Yeah.
chapter 7 as far as I remember. So we are two lesson ahead, two chapter ahead of your main class.
Yeah.
It's so use the given areas to find the base or the height of each parallelogram. Okay, here, wait, draw a pictures quickly.
No, sorry, I did that on accident. Did you see that? The raising my hand. The raising the hand.
Okay, that's why I heard. I view my view is only like on the
The
PowerPoint
slide.
slide, yeah. So I need to like come back to see.
Yeah.
Okay, this one and next this let's say the here, not the shape, but it's look like okay, and the other one is and we have this 12 meter. This is 2 millimeter. 2 meter. Okay. This is 2 millimeter. And next, on the shape have to be like this. Okay. Okay. This is y centimeter, 5 centimeter, and okay, we need to wait here to we bring to front this okay, the other ones from here to okay. Take a little time so that this area area equal to 60 meter square. Okay. And assume this is square. Okay. And this is 6 millimeters square. Millimeters square. And last one. This area is 30 centimeters square. Okay, so choose the blue. I bring the square meter square. Okay.
Yeah, I got the answers.
You got the answer?
Yeah,
Okay, so the first one
I got 5
you got.
as the height.
So okay, very fast. So the question is either find the base or the height, right? It's either find the
Yeah,
base of the height. So
yeah.
this is A, B, C. So for A, what do we have?
For A we have height, and for B and C we have base.
For A, we have
Or
here.
like we need to find the height and the, yeah,
Yeah, we
you know.
find the highs. We find the highs.
For A and for B and C, we find the base.
For B, we find base. Yes. And okay, why I write this? We find base, and C also we find base. Correct. Sorry. So how do we find heights from the figure A? From the figure A, how do we find height?
For figure A, I divided 60 by 12, which equaled into 5.
Okay, so don't skip the original formula. The original formula is the area, starting from the area,
Yeah,
equal to base times the height.
yeah,
So in order to find height, we take the area divided by the base, which is 60 divided by 12,
equals 5.
5. What is the units?
Oh, millimeters. Well, meters squared.
Me, unit
Because
unit of the height is
is it millimeters squared because you only put one m
not square. It's just meter.
meters?
It's just a meter. Why?
Oh,
Because like
oh,
area should be like meter square, divide by meter, then it will be meter only by
Yeah.
meter, right? So height, basically like a length. For the height, the base, the whatever, only the length, no square. But for the area, it have to be square. For the volume, it will be like cubes, but it's a three-dimensional, so cubes. Okay. Next, for B, we are looking for the base, and then
I
similarly, yes, yes. What is your answer?
the base I got 3.
Three. Okay, yes. So for B, we do the same with the formula base times the height. To find the base, it's area divided by the height. So the area is 6, divided by the height is 2, is 3 milli.
Meters, millimeters.
Yes, millimeters.
You
Uh,
can use this here.
Next one is C. What is your answer for C?
For C, I got 6.
6. Okay. So similarly, the area equal to base times the height. The base will be area divided by the height. 30 divided by 5 is 6 units is
It's 6 centimeter.
centimeter. Correct.
You
Okay.
spelled it, man.
Okay. So for the, I think like parallelogram, it's easy for you.
Yeah, it's just basically dividing, and I'm really like good in that. You know what I'm talking about?
Okay, okay. So let's use the, let me go a little bit further. Let us further question. Okay, so this one is applications problems, but related to the parallelogram still. So we have Sasa is buying a paint for a design on a wall. He is the part of design. Okay, I will draw a shape letter. Say, shape B will need more paint than shape A. Do you agree? Okay, do you agree? And why? Okay, I will draw a shape. First, it's a rectangle. This is a wall, and then we have wall shape A here. This is shape A. Mark it as okay. Cut it here. Okay, this is shape A. The other one is shape B. Wait, where I put where's the point. Do this as the different color B? Okay. Text, 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 text. Hmm, let's do this. This is A. Okay. Let's take a little time for the drawings. A here. B here. Hmm. Okay. This is polygon. This is 1 meter. 1 meter. The other one is 1 meters. Okay. So, is the figures. So the blank one, the white one is the wall areas, but haven't painted yet. And for the rectangle shape, the A is painted in blue, and the B is shape is painted as in the parallelogram shapes,
Yeah.
orange. And Sasa is the one who paints, and she said that Sasa is buying the paint for design. Okay, she say that the shape B will need more paint than the shape A. Do you agree? Why? Do you agree or I don't agree? Any ideas? Do you agree or no? I don't.
I think yeah, because it's longer and more like yeah, you know what I'm talking about? It's like longer. It's like it's more painting.
Yes, it look like it more painting, but
Yeah.
how do we know the amount of paint that have to be painted? We need to find the
We need to find the area.
area. Yes. Okay. So to find the area for shape A, let's say, how do we find the area for shape A? What is shape A?
Oh, it's a rectangle, so we don't have to do base times height. Instead, we do like length times width.
Yes. Now, what is the length and what is the width?
Isn't it just like wait?
We
So the width is like 1 meter.
the width is 1 meter. Okay. How about the length?
It doesn't really necessarily say anything, but
It doesn't say. So let's say the length is L, right?
yeah,
So the area for shape A is 1 time L is
one
wait one.
or L.
Yes, is L. Let's say L meter square. Correct. This is
Yeah,
shape A. How about for shape B? We also need to find the area as
length
well, right?
or I mean yeah,
That's the
area.
area for parallelogram. Let's say area for shape B. Let's do this. A. Okay. So it will be the
Is it like
parallelograms. Yes.
yeah?
It will be
So it's base times height.
base time the height. Base time the height. What is the base for the parallelogram B?
1 meter.
1 meter. How about the height for the parallelogram B?
I don't think it really says anything, does it not?
It doesn't say, but the height should be from here, right? From the corner here perpendicular to the base, which is this length, right? This distance.
Oh, yeah.
This distance equal to what? Is it equal to the length of this rectangle or not?
Yeah, it is.
It is, right? So this height also to be L, correct? This
Correct.
height is equal. Okay, basically it's a height, but the height equal to L. So then 1 meter times L will be
Just like L squared, meters squared.
meter square. Now, do you see this is more dense or not?
More what?
So the question, Sasa say,
Is
do
it like the same thing? Cause like we don't know what the height or the height or the length is.
so basically the area of the A and area of the B are the same, right? So area of A and area of the B will be L meter square, which is
Yeah.
the same. So now, do we agree with Sasa?
No.
No, we don't agree with her. So, do you agree? No, because the area are the same, right? So, no, because the area are the same. Because
Yeah.
area the same. Mhm.
No,
Okay.
he's wrong because it's gonna be like the same answer.
Yes, we have the same answer. So, I don't agree with her statement because this proof.
Yeah.